Welcome back to this engineering economics video in which we're looking at this example problem where we are looking at spending $1.8 million to upgrade machinery to receive $908,000 in annual savings, 50% of it which will be realized in the first year, 75% in the second year, then 100% after that. After 7 years, the equipment will be salvaged for 20% of its original investment cost, and we want to know what the payback period is. So we had, in the last video, developed this spreadsheet in which we looked at the savings each year, the investment, the salvage, and then what the cash flow would be from this investment. And by calculating what the cumulative value is, we can see we start off at $1.8 million in the hole, but then we get $454,000 in savings. So that starts to reduce our deficit. And then we get another $681,000. So again, the deficit is reduced. And then in the third year, this $908,000 worth of savings brings us into the black. It takes us from being $665,000 in debt to having a positive balance of $243,000. So we had left off in the last video saying we know that the payback period is going to be somewhere in between these 2 years. So somewhere in between years 2 and 3. Now if we want to get a little bit more precise than that, here's how we can do that. So I'll just write in here payback period, and we can simply calculate. It's going to be 2 plus something. We can see that, right? At the end of 2 years, we still have a negative balance. At the end of 3 years, we no longer have a negative balance. So it's going to be 2 point something, but 2 point what? If we were to divide this year up into tenths or hundredths, what decimal, what fractional part of a year would be required for this balance to hit exactly 0? So it's going to be equal to 2, we know that, plus some part of a year. And the way we can calculate that part of the year is, in order for this balance to be 0 from the end of year 2, we need to make $665,000 exactly. If we were to make or save, because that's the way the problem is written, savings, if we were to save $665,000 exactly, then our cumulative balance on this project would be exactly 0. And that means that the original investment will have been paid off. Now, if we look at how much money we are going to make in the following year, in year 3, that's $908,000. So if we wait for the full year to go by, we're going to go past that point where the balance is 0. So in order to find out what portion or fraction of this amount will get us to exactly 0, we want to add to our value of 2, 665. I could put in 1,000, but I think I'll just drop the zeros off. 665 divided by 908. Or actually, I guess what I could do is I could use cell references. I could say it's 2 plus, actually it would be minus because this is a negative value here. That divided by that. And I can see it's going to be 2.7 if I reduce this down to maybe I just want to know it to the 10th of a year. So 2.7 years. Okay, and if without the cell references, if I just typed it in, it would be 2 plus, because it's going to be 2 full years, and then some. And the then some would be however much time it takes us to make our $665,000, when in the following year, the total amount of money we're going to make or save is $908,000. So again, either way, whether we use cell references or just simply type it out, the payback period for this investment is 2.7 years. Okay, and if we wanted to know to the nearest hundredth of a year, 2.73 years. So this is a method of screening projects that we are not yet considering the time value of money. We're just simply looking at the face value of this money without considering any type of opportunity cost. So is 2.7 years short enough, or is that too long? We can't really say from the information provided. That really depends on the company. Maybe they think, sure, they're willing to wait 2.7 years to see a profit. They can get by that long while operating in the red, as they say, having negative values. In fact, I could format these cells to show negative values actually as being red. And you can see here that illustrates where that expression comes from. We're going from in the red to in the black. We're going from a negative to a positive balance. So is 2.7 years too long or not? If the company is financially stable and they're not hurting for money, they might be willing to wait 2 years to see a profit. And I would think if they have $1.8 million to invest, they could probably stand to wait a couple years. Okay, let's move along now to look at a discounted payback method. So in the previous example, we did not consider any type of opportunity cost, meaning if we didn't invest in this particular project, if instead we took our money and invested it elsewhere, and we could make a profit on it of some percent, that's going to potentially change the payback period. When we look at the time value, if we just consider present values of these future monetary amounts. So we're going to look at the same example from the previous slide. And this time we're going to assume that we can earn a 15% per year interest rate. So an annual rate of 15% is what we could earn if we decided to take our money and invest it elsewhere. So I've got my same spreadsheet from the previous example problem that has our savings per year, our initial investment amount, the salvage we get back at the end, and we add those all up, and that gives us our cash flow value for each year. And I've got this cumulative column here as well. What I'm going to do is I'm going to insert a column here between cash flow and cumulative. And I'm going to call this cost of funds. So what this cost of funds is basically telling us is if we could have invested in, if we could have taken our money and earned 15% on it, what would that be? What would that 15% be? And so what we want to look at is the 15% of whatever our balance is for the project. So we can say that in year one, it's going to equal 15% of 0.15. Must have skipped my decimal place. There we go. 0.15, 15% of this $1,800 or $1.8 million. So in these early stages of the project, when we are still in the red, when our cumulative balance is negative, we can actually think of these cost of funds as the interest being paid on the loan. This is 15% of all this money that we have borrowed. And I think I need to adjust my cumulative row here. Yeah, I want to take our balance plus the cash flow plus our cost of funds to give us our new balance. Okay, and we're still in the negative. We still have a negative balance, so we're going to need to, again, we can think of this as paying 15% interest on this debt. And if I copy this one down, and copy this down as well, what we're seeing here is that, okay, so we still have a negative balance of 1.6 million. We're paying $242,000 on that in interest. Then that new cumulative balance becomes 1.1 million. Again, we're paying interest on that. 446,000. Again, we're paying interest. And it's when we finally get into the black that we have this cost of funds here being positive. And so you may think, well, why do we have a cost of funds if we've paid off our debt? We've paid off the loan. We're in the positive now. Why do we still have a cost of fund? So the way we can think about this is that once we finally get a positive balance in year 4, when we finally are in the black and we have this $395,000, we're not just going to stick this under the mattress or stuff it in a coffee can. We're going to put this money to use. We're going to invest it at that same 15% rate. And so going forward, we're no longer having to pay interest on our debt. We have a positive amount of money that is going to earn us money. So we're going to take this money and reinvest it. And so this cost of funds column starts off being negative, but eventually flips to positive when we have that positive money that we can start to invest. It's going to just continue to make the project balance grow even more. And so if we're looking at our payback period here, when we did not consider the cost of funds, we had a payback period of 2.73. So if we look at the discount payback period, it is going to be what? It's going to be somewhere between years 3 and 4. In year 3, we still have a negative balance. In year 4, we have a positive balance. So it's somewhere in between 3 and 4. So it's going to be equal to 3 plus what? We have to make this much money. If we're at the end of year 3, we still have a negative balance of $446,000. And so that's how much money we need to make or save in the following year. And I've just realized that it would actually probably be better if my cost of funds column was to the left of my cash flow, so that the cash flow value included this cost of funds. Do I have time to fix that? Yeah, let's go ahead and I'm going to fix that real quick. I'm going to cut that column and paste it here. No, don't want to do that. Let's there we go. Insert cut cells. So I cut and insert these cells, and so the cash flow formula, I want to adjust this to include this column E, the cost of funds. Copy that down. And then I also need to adjust my cumulative amount here. So now, because I've changed it so that my cash flow includes cost of funds, I don't need to add both of these, because if I did, I would be adding the cost of funds twice. So now that my cash flow includes the cost of funds, I just need to take the previous year's balance plus the cash flow amount. So I'm going to delete that, pull that down. And so in order to find my discount period, it's going to be equal to 3 years plus, or in this case negative, because this is a negative value, this amount of money that we still need to make in order to reach a balance of 0, divided by the total amount of money I'm going to be making in the next year. And so that gives me my discount period, or discounted payback period, 3.53. So you can see when you take into consideration the cost of funds, it does add to the payback period.